So we have the last example for this tutorial. A small river, 40 meters wide, and 6-meter deep, flows at a velocity of 2 meters per second. If 20% of this flow of the river is diverted through a run-of-the-river hydroelectric system that generates electricity at an efficiency of 90%, what is the output in watts electrical? So what is the power output for this system? So in this example, this is a run-of-the-river flow hydroelectric system. So run-of-the-river, okay, hydroelectric. So what are given here? So we have the size of the river. So how does it look like? So let's draw a little bit of this schematic. So we have a river system. All right, so this is a river here, and there's a flow, and so this velocity here is 2 meters per second, and then the width of this river is 40 meters, and the depth of this river is 6 meters. All right, so this is the river flow, so that's the depth here. So flowing river, and then it has a diversion. Okay, so part of this, so this diversion here is running through a system on a generator here, hydroelectric system, so run-of-the-river hydroelectric system. So now, so this flow is 20% of the flow, all right, coming out of the system. So now this river will generate power. All right, so that is the run-of-the-river system. So the given now, we can get the, okay, so we have the river depth, width of the river is 40 meters. The depth of the river is 6 meters. All right, velocity is equal to 2 meters per second. And then we are given that 20% of this, so 20% of flow rate is also diverted to run-of-the-river hydroelectric system, and then efficiency is 90%. So question is, what is the power? Oh, sorry. So this should be power in terms of watts electrical. All right, so that is a question now. Okay, so coming from that, I think is quite straightforward actually. So let's take first what is gonna be the formula, the overall formula for this power that we need to do for run-of-the-river system. So what is the formula? So solution. So I think we need to put first the formula for power here, which is equal to, in terms of run-of-the-river hydroelectric system. So this one is in terms of kinetic energy. So we have 1/2 mv squared. So that is the kinetic energy of the river to get the power. All right, so we need to see this one. So what is m? M is mass flow rate. Okay, mass flow rate. So in this case, we need the mass flow rate of the system because this is not given. Velocity is given. Okay, this is given. Mass flow rate is not given. So in order to get the power, we need to check the mass flow rate. All right, so let's first take a look on what to do with this system here. So the first solution is to know basically what is the mass flow rate of the system. So mass flow rate is in terms of kilogram per second. So in this case, we have rho q. Okay, so rho q is basically, as I mentioned earlier, this is volume flow rate, and rho is the density of water. All right, that is 1,000 kilogram per cubic meter. So what is the volume flow rate of water? So now Q we can get the volume flow rate by area cross section times the velocity, right? So in this case, we have area of the river, which is 40 meter times 6 meter, all right, times the velocity. So in this case, we have the Q of 480 cubic meter per second. So now we have Q, we can solve for m dot, or mass flow rate, which is raw Q is equal to 1000 kilogram per cubic meter times 480 cubic meter per second is equal to the mass flow rate of the water. So how much is that one? Okay, so let's try to calculate. So this is 480,000 kilogram per second. But please remember that in our problem, only this one is actually 480,000 is basically this part here, the volume flow rate of the whole river. But we are only going to take this part here, which is only 20% of that flow rate. So in this case, we can get, or we need to calculate the 20% of that mass flow rate. So 20% of mass flow rate is equal to 480,000 kilogram per second times 0.2. So in this case, we can have the answer 96,000 kilogram per second. So now, based from this, we can now solve for P. So P is equal to 1/2 mass flow rate mv squared, and of course we have to multiply this one with efficiency. All right, so we get 1/2 m is 96,000 kilogram per second times the velocity, which is given here. This is velocity, 2 meter per second squared, and then times the efficiency of 90% is equal to 173 kilowatt of electricity. So in this case, this is the answer in terms of kilowatts, so we can put this one as 170,000 watts of electricity. So this is the power for the run of the river system in this example.